Today in this video I am going to explain that how you have to solve the circuit using Kirchhoff rules. So in the given question, what you have to do, you have to apply Kirchhoff rules to calculate power consumed by resistance of 4 ohm, and you can calculate power only by getting the value of electric current flowing through this 4 ohm. So the first thing that you have to understand is that how you can calculate value of current using Kirchhoff rules. Now the main rule that would be used here is the loop rule. As you can see, there are two loops, so you have to apply loop rule in both of them. And if you remember that video when I told about Kirchhoff rules, that you have to assume any direction of loop, that is clockwise or anti-clockwise, depends on you. So for example, in this loop I am taking direction to be like this, okay, clockwise. I am taking clockwise direction. Now if I am taking clockwise direction, when I am going in this direction, the resistance is 4 ohm and the current is I1 plus I2 in 4 ohm. So I am going like this and current is coming like this, so I am in opposite direction with the flow of current. So I would be taking negative sign for that, that is the sign convention, minus 4 I1 plus I2. Now when I go more further, there is a 2 ohm coming, and in 2 ohm I1 is flowing and I1 is coming like this and I am going like this, so again in opposite direction, so it would be minus 2 I1. Now about EMF. Direction of EMF, the loop is going from negative terminal to positive terminal, so that's why positive. These all are sign conventions that have been told to you earlier also, equals to 0. Now if you simplify it, this is minus 4 I1 minus 2 I1 gives you minus 6 I1, minus 6 I1 minus 4 I2 equal to minus 12. If you simplify this equation more, you can neglect negative signs and you can take common 2 also, so it becomes 3 I1 plus 2 I2 is equal to 6. Let this be your first equation. Now there is one more loop and I am taking direction like this, that is again clockwise direction. Now if I take clockwise direction, when I am going like this, the resistance in this loop is only 4 ohm and I am moving like this, current is also moving in same direction, so it becomes plus 4 I1 plus I2, and there is no more resistance in this loop. You are only left with the EMF of cell, that is 6 volt, and you are going from positive to negative terminal, that means negative minus 6 is equal to 0. Now if you simplify it, you get 4 I1 plus 4 I2 equal to 6. This is your second equation. Now you just have to solve these two equations simultaneously. So for solving this, what we can do, we can multiply this equation by 2, so this becomes 4 I2 and this 4 I2 can be subtracted. Now if we subtract these two equations after multiplying 2, this 4 I2 would be cancelled, 3 2s are 6 I1 minus 4 I1, you get 2 I1, 12 minus 6, you get 6, and I1 is 3 ampere, so you get the value of I1 to be 3 ampere. Now if you substitute this value, 3 3 is 9, 6 minus 9 is, you just put the value, 3 3 is 9, 6 minus 9 minus 3, and I2 would be minus 3 by 2, that is minus 1.5. So I2 is equal to 1.5. minus 1.5. That is in minus. Now I1 plus I2, that is 3 minus 1.5 would be 1.5 only. So the current flowing through 4 ohm is 1.5 ampere. Now if you want to calculate power, power is I square R. I square R, that makes it 1.5 into 1.5 into 4. 1.5 square into 4, that is 2.25 into 4. That is 9 watt. So the power across or consumed by 4 ohm resistance would be 9 watt.